So here we have Docker Swarm. Is a Docker inbuilt container orchestration kind of solution where we can deploy our applications as the stacks and Kubernetes. Say a lot of people will ask us, or even client also ask us, why we need to go for Kubernetes if I have already a solution from Docker like called as Docker Swarm. Okay, so with the Docker Swarm, what is the main disadvantages? There is no scalability. So what is the meaning of scalability is if I have more number of users are there, okay, so it's not proven. So Docker Swarm is claiming they can bear it, but there is no proven solutions for that. But for Kubernetes, the proven solution is okay. So there are some thousands of applications are used huge workloads. So one of the best example is Google. Okay, so most of the Google applications have been deployed on top of Kubernetes itself. That means it's a very, very good proven solution. It's already the production workloads can be manageable. So where there is no scalability,
Docker Swarm.
yeah, Docker Swarm doesn't have the scalability. Okay, next one. Production workloads, there is no proven solutions. Okay, so there is no proven solutions for production workloads. Okay, so to whom we don't have. Docker Swarm didn't have. Okay, so whereas Kubernetes is having some thousands of proven solutions that there is already proven one. So there is no self-healing kind of features. Auto scaling or cluster auto scaling. Okay, automatically we can increase even the cluster size also, self-healing. Okay, so load balancing also. Cloud integration also very good with Kubernetes. Okay, so Kubernetes also very good. And it's an open source itself. Any of the open source application you want to get success in the production, it required very good community support. Okay, so we have a very good community support also is available for Kubernetes because Google is there in the backend. And a lot of companies also providing a lot of plugins and a lot of support also, drivers, all those also they are providing. So that is also one of the advantage Kubernetes is getting popular. Okay, so then so what may be the limitations or advantages of Docker Swarm is Docker Swarm is easy to say even bootstrapping of the cluster also yesterday we very easily we bootstrapped whereas Kubernetes is little tough to manage. Okay, so whereas Docker Swarm is very easy to use. Okay, so Docker Swarm is very easy to use whereas Kubernetes is little challenging. But once we move to EKS or AKS, most of the complexity of that also has been reduced because it's easy to use it. Okay. For small and medium excuse me, application deployment, we can use Docker Swarm. For medium to very high level, it's recommended to use Kubernetes. Okay, so small, medium, I don't increase than medium, then better to go for Docker Swarm. Like this, people will ask us, so what are the differences between Docker Swarm versus Kubernetes? So Docker Swarm versus Kubernetes. Any doubts on this?
No, sir.
Okay, so that's the scalability, high-end, millions of requests can be handled, all those. Docker Swarm also claiming I can do all these, but not proven at the production. Okay, so not proven at the production. So that is the reason we are going to use the Kubernetes. Okay, so Kubernetes has been is a Google product. So internally, most of the Google applications have been used with Kubernetes, but they made it open source. So in order to contribute, Google is getting a lot of success, a lot of contribution from the companies, and in order to support their own deployments, Google made Kubernetes as an open source. Okay, so from that, OpenShift is there previously, which is an enterprise support version that has been moved to most of the workloads from OpenShift to move to Kubernetes. But even if you know Kubernetes, easily we can work with OpenShift also. That means if they have the OpenShift also, they will consider if we tell you have knowledge on Kubernetes. Okay, so it's a Google product, but they release into open source. Yeah, so what is the like Kubernetes? We'll discuss what exactly Kubernetes and what are the architecture components we have. Okay, so what are the components we have in the Kubernetes? We'll discuss. So the shortcut for Kubernetes is K8S. Okay, so why it is called as K8S is between K and S we have 8 letters. So that is the reason K8S. So some companies will use the term called K8S or Kubernetes. Okay, so in the Greece, like the Kubernetes meaning is either is a pilot or a governor. Okay, so what it is piloting or governing? What Kubernetes is pilot or governing?
Containers.
Yeah, containers. It's a container orchestration is the better word than pilot or governor kind of thing. Okay, it's going to orchestrate the containers. Okay. On top of any container runtime. So it's not mandatory. It should be Docker only. Okay. So Kubernetes can use any of the container orchestration kind of tool. Okay. So on top of that, we can orchestrate. But we are using our container runtime is
Docker.
Docker. Okay. So it's not mandatory. We should require uh, container runtime should be Docker. There is runc, podman, CRID. Okay. So most of the container runtimes it supports. Okay, so then what is the meaning of orchestration kind of thing? Automatically provisioning the containers, scale up and scale down, load balancing, So we can do the load balancing, self-healing, destroy. Okay, say update. Say at the container level, we may have thousands of microservices. What orchestration can do? So what orchestration can do? It can do automatically provisioning the containers, scale up and scale down kind of containers, load balancing. If any container having any issue, automatically it tries to resolve that one and destroy the containers also. And the updates and rollbacks also can be performed. So if you have any newer version of images coming, we can update. And if you want to roll back also, we can do rollback. So all this we can do through Kubernetes. All this we can do through Kubernetes. Okay. The Kubernetes architecture. So in the Kubernetes architecture, normally any of the cluster, even in Docker Swarm also, we have master and we'll call it as manager. Okay, and workers we have. So now here, Kubernetes master we have, or now that's called as control plane. Okay, control plane. Takes control in the complete Kubernetes. Second one is nodes. So very old, those nodes are called as minions. So now we are not using the word called minion. Very early stage of Kubernetes. Those are called as minions. So those nodes are called as minions. Okay, so can you tell me what are the components we have? So we'll have master, or that is called as control plane. And the second one is
Nodes.
Nodes. So the very old name is
Minions.
minions. So now don't tell minions. Okay, nodes itself, or maybe we may call as workers. But workers is not Kubernetes terminology. Workers is
Docker.
yeah, Docker Swarm. Any cluster will have like a master and slave kind of architecture. Master and slave will have some hundreds of slaves reporting to master. Reporting to master. Okay, so then what are the master components we'll discuss. If I install a master, first we need to initialize using kubeadm something. In the master, we have the components like API server. What is the first component? API server, scheduler, controller, etc. So we have the 4 components in the master. What are those? API server,
Scheduler
controller,
and etcd.
and etc. Okay, on the agent side, on the node, we have Kubelet, Kube-Proxy, container runtime. So what is our container runtime?
Docker.
Yeah, our container runtime is Docker. On top of that, we have the pods. On top of that, we have the
Pods.
pods. Okay, so can you tell me what are the master components?
API server scheduler.
On the add-ons also we have. Okay, so some CLI tools, all those we'll discuss. Can you tell me what are the master components?
API server scheduler controller is etcd.
etcd. Okay, on the agent side,
Kubelet, Kube-Proxy, container runtime and pods.
yeah. So now if you go for the API server, if you type something in the command line, okay, say if you type Docker daemon will take those. If you type anything in the kubectl, so now here we have two types of command line tools. One is kubectl, second one is kubeadm. So kubeadm is only for bootstrapping the cluster. Bootstrapping means initializing the cluster or joining the cluster. Yesterday we done through Docker Swarm, right? Docker Swarm is the command to do the bootstrapping. So here in the Kubernetes,
Kubeadm.
okay. So to manage Kubernetes after bootstrapping, to manage Kubernetes workloads, we can use kubectl. Say you want to deploy deployments, all these like normal Docker commands like that. Okay, so we have two command line tools. If you type something in the kubectl, okay, so it need to communicate with the Kubernetes. So which component of master is responsible for that? The front end of Kubernetes cluster is any of the request it will take by
API server.
API server. API server will take any of the request. If the request comes from okay, say from the CTL or some command line or from dashboard or from third-party tools, I want to do something in the Kubernetes cluster, that API server will take. On the agent side, okay, in the node, what is the agent? Agent is Kubelet is the agent service. Okay, so Kubelet is the agent service that also start reporting to
API server.
API server with the Kubernetes, because any agent need to report to the manager or not. Okay,
Yes.
the Kubelet service should be running in the node or not. If the Kubelet service is not running, then that manager will assume that service is some health issues. Okay, so that is the reason the Kubelet service should be running each and every time. Any doubts?
No, sir.
The Kubelet service should be running. Okay, then what is the role of scheduler is, scheduler will decide, okay, on which node, okay, that say here we'll call it as pods, where those pods are running. Say yesterday also, if we deploy 6 replicas, 3 replicas run in one worker and 3 replicas in another master. Like this, here, who is going to take the responsibility where the workloads need to run, where the pods need to run? Who is taking care?
Scheduler.
Scheduler will take the decisions of, okay, so where the like pods need to run. Okay, then we have etcd is a key value store. So what is the meaning of key value store? Is it's a database kind of thing. For any of the cluster, it need to store the database. All the meta information, what are the nodes we have, what are the workloads we have, all those details need to be stored somewhere. Okay, so that's a key value NoSQL kind of store. It's an open source NoSQL kind of thing. For cluster, if you use MySQL or Postgre, it is very tough to manage. So that is the reason most of the clusters are using internally etcd. If someone asks about etcd, what is that? It's a key value
Pair.
store. Key value store, storing all your meta information regarding the. So if you have a student project, all the student details will store in one database or not?
Yes.
Okay, if you have an employee project, employees details need to store somewhere. Okay, so in the same way, all Kubernetes cluster details we are storing in
etcd.
the etcd. It's a key value store. Then how many nodes are running? How many pods are running? Okay, so what are the service endpoints? All this controlling can be done through controllers, and if those are not running, it will make sure to run those. Okay, so we'll have the controller also, will control the node level, pod level, service level, endpoint level. These all going to work. So we'll discuss today. We don't understand all these, but have a basic overview. When we are going to work with all the resources, practically we'll understand. But everyone should be able to tell so these all the components. Okay, so can you tell me what are the master components?
API server, scheduler, controller, and EC2.
Yeah, on which node, which pod need to run, who will decide?
Scheduler.
Okay, so Kubelet will communicate with
API server.
Kubelet will communicate with the API server. Okay, then how many nodes are running? All this can be managed by
Controller.
controller. Okay, so dashboard can communicate with which component? If you have a GUI-wise dashboard, with which component it's going to communicate? The GUI, CLI, third party, anything you want to communicate with the Kubernetes,
API server.
API server itself is the front ender. API server itself is going to communicate. Okay. So then on the agent side, can you tell me what are the services we have?
Kubelet, Kube-Proxy,
Kube-Proxy,
container runtime, pods.
container runtime. Okay. So can you tell me what is Kubelet?
Kubelet is which runs in every pod.
Yeah, it's an agent kind of service. It need to report to the manager what's happening in the worker. Or what's working in the, okay, in each and every agent that Kubelet should be working. Okay, Kube-Proxy is the network kind of service for the pod-to-pod communication. To expose the pods, we require Kubelet. Sorry, Kube-Proxy. It's a network service on the agent in order to communicate with the pod-to-pod communication, node-to-pod communication. All these are going to happen through
Kube-Proxy.
Kube-Proxy. And in order to run the containers, one container runtime is mandatory. One container runtime is mandatory. Okay, so then we have two command line tools. One is kubectl. Say we just like how we work with most of the workloads on Docker, we work, right? In the kubectl, every day we are going to use. KubeADM we don't use because we are not using KubeADM to bootstrap. That's all part has been taken care by EKS itself now. Previously, we used to use KubeADM. Now you don't need to work because that's all managed by
EK.
Yeah, EKS itself. EKS also given on top of EKS, they given their own EKS CTL tool. So only it works for EKS only. They have given their own command line tool also. Okay, so then we have some more like Kubernetes dashboard. Instead of using a kubectl, everything we can manage from GUI wise also. Okay, so that is the dashboard we have. Then a Kube DNS is there. So internally we required a lot of resources would be created for that internal mapping. All those we have through Kube DNS. The Kube DNS would be there. Okay, so what is the Kube DNS also we'll discuss. There are a lot of internal add-ons we have. Those all add-ons on top of Kubernetes cluster we can create. And in the very early stage, Kubernetes bootstrapping is very tough process. Okay, then it need definitely a Kubernetes administrator. In those days, developers for dev and QA environments, instead of using a Kubernetes cluster, they used to work with Minikube. Okay, so master so as of now, we don't need to use Minikube because bootstrapping the Kubernetes cluster has been simplified. But 5 to 6 years back, bootstrapping the Kubernetes cluster is very tough process. And resource also not available. I required minimum 2 servers. But if I go for Minikube, what is the advantage?
You can have only one server.
Only one server, but it's not for the production workloads. It's not for
Production workloads.
production workloads. Okay, we used to use this for dev and QA environments itself. Nowadays, bootstrapping is not a big issue because if you use the EKS kind of clusters within 10 to 15 minutes, we can bootstrap. Okay, so that is the reason you no need to use Minikube. You no need to use the Minikube kind of thing. Okay, so once you create the Kubernetes cluster, by default, I'll today discuss the brief idea of all the resources. From tomorrow onwards, we'll discuss more. Okay, so we have namespaces. So what is the namespace? In Linux, namespaces are different. In any programming language also, we may have the namespaces. But in the Kubernetes, the namespaces is it's a virtual cluster where we can allocate the resources, where we can allocate the resources. What is that meaning is we can allocate the resources for the teams. I have multiple teams. Like if one team consumes more cluster resources, we'll get a shortage of resources to other teams. But here I'm going to split that into multiple namespaces. For every team, I'll allocate one namespace. Use only those resources itself. Okay, so what is the advantage? Then they can't complain with other teams. Other teams are consuming more resources to me. So that is the reason in the real time, we are going to work with namespaces and we are going to create our own namespaces and we are going to access the resources within the namespaces itself. Yeah, any doubts on this?
No, Stefan.
Okay, so we need to work with the namespaces. By default, we'll get 4 namespaces, but we need to create our own namespaces. We need to create our own namespaces. Then on top of this, we are going to deal with the pods. So now I'll try to explain what is a pod is. It's a encapsulation of like a container, their network and storage managed by Kubernetes. So whereas container is managed by container runtime. Okay, in our scenario, it's a Docker, but that Docker container volume network as a single entity. So what is that encapsulation? I'll tell one example. If we go for an EC2 instance, it's having a computing resources, storage, and network resources all have been into one entity we are calling as instance. Okay, so here instead of virtual machine, we have a container network, container volume, all encapsulated into one entity called as pod. The pod is the lowest level of object managed by Kubernetes. Okay, so the pod is the lowest level of object managed by the Kubernetes. If I create a pod in the backend, what is getting created? If I create a pod, okay, so what is getting created in the backend?
Container runtime volume.
Yeah, container runtime will create one container. Even technically, when we create an instance in AWS in the backend, that is creating a virtual machine itself. Okay, so that virtual machine part
Yes,
we are not taking care. If I go for Kubernetes, that container part you no need to worry. That Kubernetes will take care. Okay, so the pod is the lowest level of object managed by Kubernetes, because container is not managed by Kubernetes. It's managed by Docker itself. It's not mandatory. You should have only one container. The 90% one pod may contain one container. There are very special cases. We'll discuss those. One pod may contain
one or more containers.
one or more containers also. We can have one container mostly in one pod. Otherwise, more containers also. That container storage network all as a one entity is called as
Pod.
pod. Pod is the lowest level of object managed by
Kubernetes.
Kubernetes. Okay, so container is managed by the container runtime. Okay. Any
Yes.
doubt? Okay, so we need to know the parts because we are going to deal with the thousands of parts in the real time. We are going to manage the thousands of parts. Then on top of the parts, we have the pod. We don't deal with the parts individually, even in the Kubernetes. We have the higher level of objects than parts. We don't deal with parts. Okay, say if in the Docker also we don't directly deal with the containers, right? What are the higher level of objects than containers?
Stacks.
Yeah, services, and on top of services we have
Stacks.
stacks we have. Okay, on top of that we have the stacks. Like this, here we have the pod controllers we have. We don't deal with the pods. We have the pod controllers. Those resources are deployment, daemon set, and stateful set. So here we have three resources. These all same purpose, pod controllers, but we have the slight difference between them. We'll discuss. We don't create pods directly. Okay, so we are going to create
Pod controllers.
pod controllers. What are the types of pod controllers we have?
Deployment, daemon set, and
Daemon set and
stateful set.
stateful set. What are these all? We'll discuss. Okay, then if I create 10 replicas here in the deployment or stateful set, if I specify 10 replicas, then how many parts would be created?
10 parts.
10 parts would be created. Like this, we don't deal with the parts. We'll deal with the
Part controllers.
part controllers itself. Those are deployment, daemon set, stateful set. Our workloads we are going to define into those.
Controllers.
Yeah, then we need to use the part controllers. Okay, so then once we deploy the part controllers, we need to expose those, okay, using the services. So by default, like in Docker, we can expose those using the port number, but by default, we don't expose those to the outside once we create the parts. Okay, using the services, we can expose. In the services also, we have the types like a load balancer. Otherwise, we have a cluster IP, node port, load balancer, cluster IP, node port, load balancer, and external name. So these all the services we have. Okay, which service we need to use on top of this? One more type is there, headless service. Okay, on top of that, we have one resource called as ingress. And these all networking related. And for storage, say in the Kubernetes, we have PV and PVC. So PV stands for persistent volume and PVC stands for persistent volume client. So in the Docker, we have the volumes right here. We need to have PV and PVC we need to attach. And what is ingress also we'll discuss. On top of services, we have the ingress resource. Okay, so as of now, these will keep and we'll discuss these. Going forward, we'll go for other resources also. So these are the very basic kind of Kubernetes as of now. Maybe previously these are very advanced, but today a lot of people are using Kubernetes. That's the reason they got good exposure. We also need to gain good expertise in the Kubernetes. Okay, so then we'll go for what are the Kubernetes maximums. So if we go for the Kubernetes maximums, okay, a cluster is a set of nodes, either physical or virtual machines running as Kubernetes agents. Okay, so can you tell me on one node how many parts we can run? In one node,
110.
110 parts. Okay, it's not possible to increase. Okay, here the version they have specified is 1.28. As of now, this is the latest version. Okay, but go through some of the stable releases because for the previous we can't tell we use 1.28. Maybe currently also we don't use directly 1.28. Maybe 1.24, 25 like this we are using. Okay, so how many parts per node? And in cluster, can you tell me maximum nodes are
5,000.
5,000.
5,000. Okay, more than 5,000. If you want more than 5,000, then go for multiple clusters. And what is the maximum number of parts in one cluster?
1,50,000.
1,50,000 parts we can have in one cluster. And what is the maximum number of containers?
3 lakhs.
3 lakh containers we can have. Okay, so that it doesn't mean that Each and every pod will have 2 containers. These are the maximums. Okay, so I think you can remember, right? These maybe in the interview they may ask us. Okay, but lot of companies having even bigger clusters than this. Bigger clusters than this we may have. Okay, so then once you set up your Kubernetes cluster and bootstrapped, we have a container interface. We have CNI. We need to add one CNI also. What is that CNI also? We'll discuss. Okay, so PV, PVC, CNI. So till this we need to discuss. Later we'll go for other components, advanced components, all those we'll discuss. Yeah, any doubts till now? Okay, so I'll stop here.
So can you please share this? Notes?
Yeah, I'll share it. Please download this. So just go through that Docker Swarm versus Kubernetes and the Kubernetes architecture one.
Okay, sir.
Yes, sir.
Okay.